Hey guys, so here's the notes for 5.4. We're going to be multiplying and dividing rational expressions. So let's first talk about how do we multiply rationals. Well, first of all, we need to make sure it's always in this simplified form. So what this means is there's no common factors other than 1. So here are the steps to multiply rationals. First, we need to factor all the numerators and denominators what we can. Once we've done that, then we're going to divide out any factors common to both. Now we're going to leave our final answer. You might want to put this down as like a number 3. Leave answer in factored form. So please write this down in your notes. There we go. Okay? So leave your answer in factored form. Okay, let's go ahead and do our first example. So we're going to simplify the rational expressions. So number 1, if we look at both the numerator and denominators, they are already factored out. So what we're going to see is there anything that we see in the numerator that we see exactly in the denominator? Well, we look, we see exactly the x plus 3. So what we do is we cancel them out. So now, whatever is left with, which is the 4 in the numerator and the x minus 5, that will be our final answer. Okay, now let's look at number 2. We have x squared minus 2x minus 15 over x squared minus 9. So notice for both of these, we will have to factor. The top, remember how to factor when our a value is 1. We do 2 sets of parentheses, x and x. We are finding two numbers that multiply to 15. So we have 1, 15, and 3, and 5. That add up to our middle term of negative 2x. Well, that's going to be the 3 and 5. To add up to a negative 2, our 5 needs to be negative, and then our 3 is going to be positive. Now let's look at x squared minus 9. That we need a factor. Notice that is a difference of squares. So we have x and x. Square root of 9 is 3. We have a minus and a plus. Now we need to see, are there any factors that are in the numerator and in the denominator? In this case, it's going to be the x plus 3. So we cancel those out. And then whatever is left, that will be our final answer. So we have x minus 5 in the numerator, and then x minus 3 in the denominator. And there's our final answer. Okay, let's go and do the next one. So now what we're going to be doing on 3 and 4 are multiplying. And so this is now going back to, remember we multiplied and we dealt with our exponent rules. We're going to be basically doing the same thing here. Just kind of a little review. Okay, so remember, when we multiply horizontally. So I need to multiply my numerators. So I do 5 times 6 to give me 30. X squared times x. So remember, when we multiply with the same base, we add the exponents. So that means, notice on this one, it's going to be x to the first. So x squared times x to the first, that's going to give me x to the cube. And then we only have y cubed in the numerator. Now on the bottom, I do the same thing. 2 times 10 gives me 20. There's nothing else left to multiply with the x, so I get x squared and then y. Now we go ahead and simplify. So I first simplify my numbers. So 30 over 20, that will now resort to 3 over 2, because know that 10 goes into both of them. Okay, now after that, I need to deal with my x's. Now remember, when we divide with the same base, we subtract the exponent. So I just get x. And y cubed divided by y, that gives me y squared. So my final answer here is 3xy squared over 2. Okay, now what I would like you to do is go ahead and actually pause the video and try number 4 on your own. Okay, let's see what you got here. So 8 times 7 gives us 56. X cubed times x to the 4th gives us x to the 7th. And y times y cubed gives me y to the 4th. In the denominator, 2 times 4 gives me 8. Then I have x, and then y squared times y gives me y cubed. Now I go ahead and simplify. Well, 56 divided by 8 does give us 7. Okay, x to the 7th over x gives us x to the 6th. And y to the 4th divided by y cubed gives us y. And there's nothing else to simplify, so there's our final answer. Okay, make sure you guys watch the second part. We're then going to go into really multiplying the rationals.